Hi everyone, my name is Lauren Powell. I work for Technicamps, which is a project within the computer science department at Swansea University. So I do have a Swansea University email as well, but I've used my Technicamps one because that's my main platform for communication. So within the department, I teach the computer security course on the Welsh BSc degree apprenticeship in software engineering programme. One of my colleagues, Philip James, who was involved in this paper, also teaches this course, but on the undergraduate degree programme, and he previously taught the course on the degree apprenticeship programme. Together with my other colleagues, Liam O'Reilly and Farah Moller, we found that our experience of teaching in school education, where we used lots of hands-on activities to sort of captivate pupils, became the forefront for how we could maybe use hands-on approach to provide a more engaging experience for students on the degree course. So this is what led us to making this change that I'm going to discuss with you today on our approach to providing security with a hands-on learning experience for teaching for security testing in a university lab environment. So we looked at the delivery of computer security courses and found that traditional approaches often consist of a lecture-led delivery, which was supported by more handwritten theoretical exercises. However, research that we completed found that to be able to enter a role in the security sector, it is desirable for students to have an understanding of real system security, but more importantly, to have hands-on experience within the computer security sector. This experience is not provided to students through the handwritten theoretical exercises that were previously taught. You tend to find that universities often take this approach due to students having limited prior knowledge surrounding the topic areas covered, and also some restrictions on the time available for running the course. This isn't the only reason that universities sort of tend to use these handwritten exercises. It's also to do with sort of the ability to carry out practical lab-based security exercises on campus equipment may often breach sort of any campus-based security policies for things like network use. Although this can be resolved with alternatives such as like a bespoke security lab, it is not always feasible when there's a need for when it's only needed for a single course within a larger program of study. Previously, this course in Swansea was delivered with 2 one-hour lectures per week, supported by a 1-hour lab, where students were expected to complete these handwritten theoretical exercises that are worth a small proportion of the assessment for the course. However, to meet these needs by industry and provide more hands-on skills, we decided to sort of have a full redesign of the lab proportion of the course, and the 2 hours of lectures have stayed the same but are now supported by a 3-hour practical lab. So the course taught at Swansea University is fairly traditional in nature and covers a wide range of topics which are quite similar to most topics taught at other university programs. They range from cryptography to blockchain technology, which you can see here. We know that for a role within the security industry, practical cybersecurity skills are desirable. The Institute of Coding in Wales Industrial Advisory Panel have helped monitor and support our degree apprenticeship programme, and their feedback has helped in aiding providers with the motivation to support students' understanding of the course content by providing a hands-on practical experience. However, we were faced with a number of challenges when trying to find a possible solution to this. Firstly, the budget for investing in the solution was limited to approximately £5,000. This restricted the possibility of a virtualised lab due to the cost of the infrastructure needed to support up to 250 virtual machines. The distribution of virtual images to students equally poses technical difficulties, because this would call for substantial bandwidth for the setup of each lab throughout the course. Although this is a possibility, current university policies prohibit being able to run these virtual machines on university machines. This solution also restricts students to working on university site. The only sort of alternative that we found for using virtual machines would be to allow students to work off site, would be to expect them to install it on their own machine, which breaches departmental expectations of the students, and you can't expect all students to provide their own machines to be able to complete the course. So to overcome these challenges, we designed a lab architecture that students could use within the university, but also could take home, and it consists of low-cost portable kits. So this is our solution. Each student on the course is provided with a security lab kit that you can see here. It contains a Raspberry Pi, a keyboard, a mouse, and a HDMI cable. In addition to the kit, for each lab, students are given an SD card containing the image of the lab task. We also purchased an SD card duplicator to allow for rewriting multiple SD cards at the same time. And also some of the lab tasks actually require additional equipment. So we've also purchased a wireless router, as well as it having to need some vulnerable machines. So we purchased additional Raspberry Pis, and we use some standard desktops as well. So these, we could then deploy the vulnerable machines across the same network. So this solution that we proposed overcomes all of the challenges discussed. All the tasks were delivered then using this setup, so throughout the whole course, and we divided the tasks into 3 different categories. The first is individual non-network tasks. So this is where students are able to explore vulnerabilities in software which is locally installed. An advantage of using this approach is that it encourages students to be sort of more playful with the software, and if they have come across any sort of issues where they maybe corrupt the software, they're able to just simply reflash the image to the SD card without then having problems and not being able to complete the task. The second is individual network tasks, which involve running network scanning tools over a dedicated network without breaching campus-based network policies. So the lecturer is able to set up vulnerable systems by connecting these additional Raspberry Pis or desktops to the network. And then these systems can then be used by the students. They're not directly used, but because they're connected to this and running on the same network, students can discover and access them remotely. The final category then is group-based network tasks. This is where students can share data with other students using command line tools over a centralized network that would usually be restricted due to the university policies. So all 3 of these categories provide students with the hands-on experience that they require, and they're able to set up and configure any tools they need themselves. So just to go over a quick example, I'd love to be able to explain examples of each one to you all, but because of time, I'm just going to show you an individual network task. So this allows students to explore network scanning using popular scanning tool Nmap. It relies on there being an additional system on the network. So we used a vulnerable Raspberry Pi, which is running a simple web server. In task 1, students learn how to scan the network and look for vulnerabilities and learn these basic tools. And then in task 2 and 3, they then are encouraged to explore a bit further, be a bit more playful and creative, try other tools to gain information to then complete the tasks. So it's not just teaching them things that they learn in the lectures, it's getting them to try and combine different areas as well. So looking at the setup in practice, there were some requirements for setting up the lab. Obviously, lecture development time is something that we didn't want it to be something that would be really big, but initially it is costly because you've got to develop these images. But once you decide the desirable operating system and software packages, this time then is reduced as you go through the course. In addition to this also, we want to offer this to other universities as well. So being able to have an open library. So this would completely reduce the development time for other lecturers in other universities if this is something they were interested in. As well, students, obviously, you tend to find that they haven't used this, a lot of these systems before and the software. So you do have a little bit of sort of setup time, but we tend to find by the end of the first lab, they are quite confident with it and have got to grasp with the setup. Obviously, we need to duplicate the SD cards, but with the SD card duplicator, that is minimal. And with regarding staff, obviously, because it's more hands-on, you might think we'd need more staff, but we tend to find because the students can set up everything themselves, there's no need for any more staff than you would have for a normal course in the degree programme. A few things then that the lab provides. It provides students with experience using a range of tools and technologies across many different operating systems. This hands-on experience is engaging and it gives them that experience that they would need for industry. There's minimal overhead for growth because we can simply just duplicate the SD cards and buy more kits. And also a final benefit is that the lab setup is available for students to be able to take the kits home and continue their learning offsite. So we're just going to quickly have a look at student performance and feedback. So we found that there was a shift in student achievement. The percentage of students passing the course has increased, and the largest component of the course is the exam, which is worth 70%. Although the lab content doesn't necessarily sort of affect the exam, we found that students were able, because they gained this practical experience, they had a better understanding of the content. And we found in their exam answers, they were able to explain the concepts a lot better. So we feel this then obviously had a overall influence on their final grades, and found that less students are now failing the exam, and as a whole students are doing better on the course. Since introducing the new lab, the majority of student feedback has been positive, with students not only commenting on the enjoyment they've had from undertaking the lab, but also they felt that they were effective in helping them understand the course content and gain this valuable practical experience. In terms of lecture experience then, we found that introducing this setup encouraged more discussion among students, not just on the topic, but further around the field as well. And also providing them with real world examples, students tended to be more engaged and asked a lot more questions about the topics rather than just simply listening and learning. We also observed students exhibited a deeper level of knowledge and understanding in their exam answers. So this is something that we really found from the feedback as well. So what's next for us? Following this, we hope to then take this back.
Time already.
Oh, this is my last slide, sorry. Can I just give me 30 more seconds? We just want to develop a capture the flag in a box workshop where we could take 15 Raspberry Pi kits out to a school and 1 laptop to then sort of simulate this in a school environment as well. So it would take a whole school day where we could teach them the resources in the morning, and then they'd be able to have a capture the flag event in the afternoon where they compete. So yeah, hopefully this is something that we'll be able to go on to do. So yeah, this is just an example of the kit. Thank you very much for your time, and hopefully this has just given you an insight into what we've done and our future plans. Thank you.